thought I'd talk a little bit about complex numbers, and I thought I'd do it here so we don't have to take an exam and do a lesson all on a Tuesday night. The basic idea of complex number is pretty straightforward. Normally in math, we say that this is a bad idea. We'd say this is undefined. But complex numbers are all about the idea of giving the square root of -1 a name, and we call that name I. This I is not to be confused. It's not the same as when I do I hat, which is a vector, meaning 1, 0. These are different. So, we want to talk about this complex I. First, a little bit about complex numbers. We've talked about the real numbers already, or you probably have in a college algebra class. And real numbers are not just numbers like 1, -1, 2, or anything like that. They also include rational numbers, things like 1/2 and 3/5. These are rationals. These are integers. But real numbers also include the irrationals. And the irrationals include things like square root of 2, pi, or the number e. But in addition to the real numbers, there's the imaginary numbers. An imaginary number is kind of a bad name. It's what we call these things, square root of -1. And they're imaginary in that people didn't think of them when they came up with these. These numbers are pretty much very, very old, over 1,000 years old. These imaginary numbers, on the other hand, are only a couple hundred years old, maybe 300. Together, the real numbers plus the imaginary numbers make up the complex numbers. And these numbers have a particular form. They look like this, where A and B are real numbers, and I, like we said, is equal to the square root of -1. So the whole goal of 4.1 is to just get a handle on how to play around with things of this form, A plus BI. So we want to do two things anytime I have a number. I want to be able to talk about a little bit of what it is, which we just did, and I want to be able to do operations on it. And we know what operations are: addition, subtraction, multiplication, and division. I'm going to focus on these first three. So let's talk about an actual honest-to-goodness 2 plus 3i. If I want to add this complex number to another complex number, let's say 4 plus 8i, well, here's what I'm going to do. I'm going to add the real parts to the real parts, and I'm going to add the imaginary parts to the imaginary parts. Just like you do if you had x plus 2 plus 3x plus 4, you'd add the x's to the x's, you'd add the constants to the constants. Exact same idea. No real difference there. So I'm going to get 2 plus 4 gives me 6, and 8 plus 3 gives me 11i. And this would be my answer here for the sum of these two. Notice that any real number can be rewritten. Notice any real number can be rewritten as a complex by saying 3 is the same thing as 3 plus 0i. So that's something we can do. Alright, so I've talked about addition of real numbers. That's nice. We can also talk about subtraction. 3 plus 6i minus 4 minus 8i. In subtraction of real numbers, again, we're going to add or subtract like terms to like terms. So this is going to be 3 minus 4 and that part's going to be negative 1. This is my A part. And in terms of my B part here, I'm going to have 6i plus, because minus minus gives me plus, instead of 6i plus 8i, which equals 14i. This right here is my B term. So my final answer is minus 1 plus 14i. The last main thing to talk about is multiplication. This is going to come in two flavors. If I have a constant times a plus bi, well, I'm going to distribute that constant and get 3a plus 3bi. This behaves just like a scalar did in vectors. And the reason we talk about chapter 4.1 after the vector section is there is a lot of similarities. So if I want to multiply 4 times 3 plus 2i, again I'm going to get 4 times 3, which gives me 12, plus 8i. The fun stuff comes when I multiply two formal complex numbers together. So let's take that 3 plus 2i, and let's multiply him by minus 2 minus 4i. To do this, I'm going to have to FOIL. I'm going to multiply my first two terms together and get negative 6. I'm going to multiply my outer two terms together and get negative 12i. I'm going to multiply my inner two terms together and get negative 4i. And lastly, I'm going to multiply my last two terms together and get negative 8i squared. So, this is going to lead us to something. On the one hand, I've got negative 6. These are like terms. It's very simple to add them together. I'm going to get negative 16i. The thing is, I don't know much about this I squared. So let's go back to what I is. I equals the square root of negative 1. If I square both sides of this equation, on the one side I get I squared. On the other side, I get negative 1 under the square root squared. This is just negative 1. This is because square and square root cancel each other out. So up here I have minus 6 minus 16i minus 8 times negative 1. I'm replacing I squared with its other identity, negative 1. So this is negative 6 minus 16i. Minus minus gives me plus. 8 times 1 gives me 8. Now I have some more like terms, these two, that I can add together. Negative 6 plus 8 gives me 2 minus 16i. My final answer for 3 plus 2i times negative 2 minus 4i is 2 minus 16i. Let's do one more. If I have negative 3 plus 4i, times 2 minus 3i. I'm going to FOIL this. Again, I'm going to multiply the first two terms together and get negative 6. I'm going to multiply the outer two terms together and get positive 9i. I'm going to multiply the inner two terms together and get positive 8i. And lastly, I'm going to multiply the last two terms together and get negative 12i squared. This is going to be negative 6. 9i plus 8i is going to be plus 17i. Remember, I squared is negative 1, so I'm going to get plus 12. This is going to give me 6 plus 17i. So there you have it. We've talked about the addition, subtraction, and multiplication of complex numbers. We've talked about the fact that I is equal to the square root of negative 1. I squared is equal to negative 1. So this means I cubed equals I times I squared. which means it equals square root of negative 1 times negative 1, which equals minus square root of negative 1, which equals minus I. So I cubed equals minus I. If I'm talking about I to the fourth, well, this is just I squared squared. So this is negative 1 squared, which equals positive 1. The i's form a pattern, and once they've gotten up here to 4, they start repeating themselves. So you play around with what I5 would equal and think about that. Next Tuesday, we'll start talking about this, and we'll move on to 4.2 and 4.